أعزائي طلبة المرحلة الثانية، السلام عليكم ورحمة الله وبركاته. Our lecture today is about an important subject in anatomy is the anatomy of liver and gallbladder. First, we'll take the anatomy of liver. The liver regarded as the largest gland in the body. Why? Because it has an exocrine function in secreting certain substances, so it is regarded as a large gland. It is wedge in shape. If we take a section in it, we can see that it is a wedge in shape, reddish brown in color, soft and pliable, and its weight in adult is about 1.5 kg. What are the main functions of the liver? It has an important group of functions. First of all, production and secretion of bile. As we said, it is a gland, so it has a role in the production and secretion of the bile, metabolism of carbohydrate, fat, and protein, filtration of blood from the bacteria, viruses, and parasites that gain entrance from the GI tract, synthesis of heparin, which is an anticoagulant, and the detoxicating function. First, the location of the liver. It is located under the cover of the diaphragm and extend mainly below the right hemidiaphragm, and it reaches even to the left hemidiaphragm. The diaphragm separating the liver from the pleura and from the lung and the pericardium and heart. It is situated mainly, the liver situated mainly in the right upper quadrant, more precisely in the right hypochondrium in the epigastric region. Usually it follows the contour of the right costal margin. The upper limit of the liver on the right side, the highest point of the liver reaches to the fifth rib, while on the left side it reaches to the fifth intercostal space. What are the surfaces of the liver? One of the surfaces that is related to the diaphragm is called the diaphragmatic surface, and the other one, or the posterior inferior surface, it is called the visceral surface, and it is molded to the nearby viscera. So it has two surfaces, diaphragmatic and visceral surface. This is the diaphragmatic surface, or the anterior superior surface. Here we can see, because it is related to the diaphragm, you can see it have no impression, nearly it have no impression. While the visceral or the posterior inferior surface, it have impressions, and for the viscera that lies nearby. What are the ligaments of the liver? The liver is kept in its position by the presence of certain ligaments. These ligaments are a double layer of peritoneum. The first ligament apparent here is the falciform ligament. And in its lower free border is the ligamentum teres, or the round ligament. The falciform ligament superior late will split into two layers, one that passes to the left to form the left triangular ligament, and one that passes to the right to form the upper layer of coronal ligament, and that of the coronal ligament, its right extremity will form the right triangular ligament. This is the posterior view. This is the right triangular ligament, and here we have the left triangular ligament, and the coronary ligament have upper layer and lower layer. In between the upper and lower layer of the coronary ligament, we have an area that is devoid of peritoneum, called the bare area of the liver. This is the bare area of the liver that is devoid of peritoneum and is in direct contact with the diaphragm. What are the loops of the liver? By the presence of the falciform ligament, the liver is divided into two main loops, larger right loop and smaller left loop. And by the presence of the inferior vena cava and the gallbladder, it will be further subdivided into caudate loop superiorly and quadrate loop inferiorly, in between surrounding the porta hepatis. This is the anterior view. This is the falciform ligament separating the liver into two loops, main right loop and smaller left loop. On the visceral surface, by the presence of the gallbladder and the inferior vena cava and the fissure for ligamentum venosum, and there is a fissure for ligamentum teres, and by the presence of the porta hepatis at the middle, it will form an H-shape boundaries that will separate in between the quadrate loop inferiorly and the caudate loop superiorly. Functionally, the caudate and the quadrate loop regarded as a part of the left loop. What are the anterior relations of the liver? As we said, it is covered by the costal margin, so it is related to the right and left costal margin, related to the xiphoid process anteriorly, also related to the anterior abdominal wall. Also, the liver is related anteriorly to the diaphragm, to the pleura of both lungs, and to the lower margin of right and left lung. All these are anterior relation to the liver. While the posterior relation of the liver, or what we call the liver bed, that is the structure that the liver will sit on it, is the diaphragm, the right suprarenal gland, right kidney, right colic flexure, the duodenum, fundus of the stomach, and esophageal abdominal part of esophagus. These are the posterior relations of the liver: the diaphragm, the right kidney, right suprarenal gland, right colic flexure, the duodenum, gallbladder, inferior vena cava, esophagus, abdominal part of esophagus, and the fundus of the stomach. All these structures are what we call the liver bed, or the posterior relation of the liver. This structure that lies posterior to the liver will form impressions. So what we call the impression of organ on the liver, this is the impression for the right kidney, right suprarenal gland, right kidney, right suprarenal, right colic flexure, impression for the right colic flexure, impression for the second part of the duodenum and the pyloric region of the stomach. This is the impression for the stomach and impression for the esophagus. Porta hepatis, or the hilum of the liver. Hilum of the liver is situated in between the caudate loop superiorly and the quadrate loop inferiorly. It is the site of entrance and exit of certain structure to the liver. It contains the right and left hepatic ducts, the right and left branches of hepatic artery, portal vein, autonomic nerves, and hepatic lymph nodes. All these structures are surrounded in between the two layers of the lesser omentum. Blood supply of the liver. Blood supply of the liver is an important subject. Why? Because the liver has a rich blood supply. It have two sources of blood supply. One for the oxygenated blood is from the hepatic artery, about 30%. Another source of blood is from the portal vein, which is about 70%. يعني راح يكون hepatic artery will give oxygenated blood to the liver, while the portal vein will give the blood that is loaded with the product of the digestion after it is absorbed from the GI tract. All this blood, after it is processed in the liver, it will be drained to the hepatic vein or hepatic veins. يعني after the blood is processed and metabolized in the liver, it will be drained back through the hepatic veins. We have 3 hepatic veins. Usually we have 3 or more, the right, left, and middle hepatic vein that will drain directly into the inferior vena cava. What is the lymphatic drainage of the liver? Because the liver produces large amount of lymph, it will drain into a certain group of lymph node called hilar lymph node, that then it will drain lymph into the celiac nodes, because the liver is derived from the foregut. Its lymphatic drainage will end into the celiac lymph nodes around the origin of the celiac trunk, while the bare area of the liver or the extraperitoneal area it will drain lymph because it is in close contact with the diaphragm. It will drain the lymph into the posterior mediastinal lymph nodes. What is the nerve supply of the liver? It is from the celiac plexus of nerve, يعني راح تكون بين sympathetic and parasympathetic nerves, and its root value will reach to the spinal cord to the segment T7, T8, T9, T10. So the pain from the liver and the biliary system will refer to this area, to the dermatome of T7, T8, T9, and T10. Also, it will refer, pain from the biliary system will refer to the right shoulder. Right shoulder, why? Because of the nerve supply to the diaphragm that is covering the liver, and we know that the phrenic nerve supplying the diaphragm, the phrenic nerve has a root value of C3, C4, enter the spinal cord at the level of C3, C4, and we know that the supraclavicular nerve supplying the shoulder region, it have the same root value like that of the phrenic nerve, C3 and C4. If we want to take a liver biopsy, we should place the needle at the mid-axillary line, intercostal space. We choose the 8th or 9th intercostal space, mid-axillary line, to go directly to the liver, and we are trying to avoid the pleural space. In this figure we see the connection through the falciform ligament. There is an umbilical para-umbilical veins. Para-umbilical vein will pass through the umbilicus with the vein through the falciform ligament to the liver. If there is a problem in the liver, like liver cirrhosis, and this is lead to portal hypertension, يعني زيادة ضغط هذا الوريد اللي هو الumbilical vein, it will lead to congestion and lead to portal hypertension, يعني زيادة بضغط هذا الوريد and lead to a condition called capotmidiosis. This is a condition caused by the congestion of the para-umbilical vein due to this connection through the falciform ligament. As we know, the falciform ligament connects the hilum of the liver to the umbilicus. It is a double layer of peritoneal connection in between the anterior surface of the liver with the umbilicus. Anterior surface of the liver with the umbilicus. The gallbladder. The gallbladder, this is a pear-shaped sac for the collection of the bile after its secretion from the liver. The gallbladder, this is a pear-shaped muscular sac lying on the visceral surface of the liver. This is the visceral surface of the liver, or the posterior inferior surface, and it has a capacity of 30 to 50 ml. Its function is to store and concentrate bile after its secretion from the liver. Can be divided into fundus, body, neck. The neck will lead to the cystic duct. The cystic duct will unite with the common hepatic duct to form the common bile duct. We can see this is the gallbladder situated on the inferior surface or the visceral surface of the liver, and its fundus will project below the inferior border or the inferior margin of the liver, and it will touch the anterior abdominal wall. The gallbladder is situated on the visceral surface of the liver in between the right lobe and the quadrate lobe of the liver. It is situated in a special depressed area called the gallbladder fossa. Its fundus will emerge below the inferior margin of the liver to be in contact with the anterior abdominal wall at the tip of the ninth costal cartilage, at the level of the first lumbar vertebra, that is, at the transpyloric plane. Here, this is the fundus of the gallbladder, emerging below the inferior margin of the liver to touch the anterior abdominal wall at the tip of the ninth costal cartilage. The anterior relation of the gallbladder will be the liver and the anterior abdominal wall. يعني هتكون الفندس related to the anterior abdominal wall and the body of the gallbladder related to the visceral surface of the liver, while the posterior relation is related to the duodenum, the first and second part of the duodenum, and the transverse colon. This is the gallbladder and its relation with the connection with the biliary ducts. This is the gallbladder. This is the cystic duct. It will unite with the common hepatic duct to form the common bile duct. These structures lie in the free margin of the lesser omentum. This is the gallbladder. This is the fundus, body, and neck. The neck will lead to the cystic duct, and we can see that the cystic duct have this elevation in the mucous membrane called spiral valve. In order to keep the lumen open of this duct, it will unite with the common hepatic duct to form the bile duct. That it will open in the second part of the duodenum. The cystic duct, this is the cystic duct, connect the neck of the gallbladder, as we said, to the common hepatic duct to form the bile duct. It is usually S-shaped, descend for a variable distance in the right free margin of the lesser omentum, and its mucous membrane, as we said, here we have these elevations. نيجي نشوفها. It is raised to form what we call the spiral valve. The spiral valve that is called the spiral valve. This spiral valve will keep the lumen open of this duct. Now we come to the bile duct. After the cystic duct unite with the common hepatic duct, it will form the bile duct. The bile duct can be divided into three parts. The first, second, and third part of the bile duct. Bile duct is about 8 centimeter until it drains into the second part of the duodenum. The first part of the bile duct is called the upper or supraduodenal part that lies in the free margin of the lesser omentum. It is related to the hepatic artery and it lies anterior to the portal vein. So it lies on the right of the hepatic artery and anterior to the right margin of the portal vein in the free margin of the lesser omentum. The second part are called retroduodenal part that pass behind the first part of the duodenum and accompany with the gastroduodenal artery. The third part اللي راح نسميه paraduodenal part. This is the first part or the paraduodenal part in accompanying with the hepatic artery and anterior to the portal vein. The second part or the retroduodenal part in accompanying with the gastroduodenal artery behind the first part of duodenum. And the third part or the paraduodenal part that runs in a groove in the posterior part of the head of pancreas. Then the common bile duct will open in the second part of the duodenum. The bile duct and the pancreatic duct, they may unite to form what we call the hepatopancreatic ampulla. This ampulla, it will causes elevation in the mucous membrane of the duodenum called major duodenal papilla. This opening is guarded by a sphincter that is called sphincter of hepatopancreatic ampulla, or another name, the sphincter of Oddi. It will regulate the passage of bile and pancreatic juices into the lumen of the duodenum. Here, this is an important clinical application regarded to the gallbladder and the biliary tree in general, which is the formation of the gallstone اللي هو حصوة المرارة. This gallstone, if it is small, it might pass through the cystic duct to the bile, to the common bile duct, and it might causes obstruction to this duct and lead to the backflow of this secretion of the bile and causes jaundice. Another important landmark here is what we call the Calott's triangle. What are the borders and content of this triangle? It is bordered by the inferior surface of the liver, by the common hepatic duct, and by the cystic duct. Inferior surface of the liver, common hepatic duct, and the cystic duct. It contains cystic artery and the right hepatic artery. This is important. This triangle is important for the surgeon to localize the blood supply, of the gallbladder in order to perform ligation during cholecystectomy. يعني خلال عمليات استئصال المرارة. Ligation of the cystic artery and ligation of the cystic duct to perform cholecystectomy. There are certain variation of blood supply to the gallbladder. يعني it might be variable. The يعني cystic artery it might comes from directly from the hepatic artery proper with certain different variation. It should be observed during operation of cholecystectomy regarding the blood supply of the gallbladder. Thank you.